All right, welcome back, everybody. I said that this was going to be OSPF version 3, and it is. But it's also because I hadn't shown you how to do a default route as well in IPv6. So we'll do a combination of both. I already took out the routing protocols from before, which was RIP-NG and EIGRP. So right now, let's take a look at our routers. You can see that we should just have basic IP here. Let me click in here. Enable, and then let's do a show start. And we still have our command, of course, IPv6 unicast routing. But we have, here's our IP address, no routing protocol, IP address, no routing protocol. All right, so we just have that basic IP addressing, the same in the other one. Let's verify. All right, enable. Now it's going to do config T. It's going to get right into it. Show start. All right, IPv6 unicast routing, that needs to be there. IP addresses, but no routing protocol. Cool. So let's go ahead. And the first thing we're going to do is let's set up a static route. Now, what we can do, just so we can see if it's working or not, we'll go ahead and have one of the PCs actually have a continuous ping of an address. So this is a PC right here in the 3000 network. So we'll have it ping. Oh, come on, mouse. Make it long there. I like to see it line by line. So we're going to ping 2001 colon, what is it? 3200. That's right there. Colon FADD colon 1000 colon 1. All right. And we're getting destination host unreachable, right? Let's make it, there you go, so we can see that. All right, so, oh wow, I said it's going to be a ping minus T. Hold on there. I said contiguous, never-ending ping minus T. There we go. All right, so it's going to be doing that. I'll leave it here on the side so we can see that it's unreachable, right? Destination host unreachable, right? Because there's no routing going on. So let's go ahead and do first our default route, and then we'll go ahead and do a OSPF. Okay, we'll do OSPF. So router 1, do config T. All right, and again, everything starts with IPv6. IPv6 route. Oops, sorry. Colon /0. That is the default. Right, like in IPv4 was 0, 2 sets of 4 zeros here. And then we're going to put the next hop address, just to make it interesting. 3200 FADD colon 2000. And the next hop address would be colon 2. All right, that would be that. That's done. Do WR. All right, let's minimize that. And you can see still still unreachable, Okay, so we're going to go to this router now, and we're going to do the same thing. Config T, route IPv6, route 0, no, not 0, sorry, colon, I got to get used to it, 0, and then next hop address back to the 2001 colon 3200 colon FADD colon 2000. Sorry, little one blank there, and then 2. Right, that's the next hop address. No, 1 is the next hop address. I'm sorry, 2. I am 2. 1 is the next hop address. Hit enter. Do the I think it changed. Do WR. Let's take a look at our PC now, and we're getting replies, right? Because now we have a default route going to the other one. That's outstanding. So let's take a look at it, how it will look in the routing table. Okay, show IPv6 route. Okay, and you can see there's your static default route, and the only reason it has a administrative distance or of 1 is because we're using the next hop address. But you can see it's going via this particular address, which is the next hop address. All right, that will be router 2. Let's take a look at router 1, and you should see the same thing. Show IPv6 route. All right, and there you go. Now I know we're expecting to see, hey, where's the default, the gateway of last resort, right? The gateway of last resort is set to blah blah blah. But here, this is how you see it there. Okay, this is how you would see it. So cool. We have a default route. We have connectivity, and that's fine when it's a very small network like this. But normally default routes, you're going to be doing them on your edge routers. You're pointing to the outside or what have you. But just so you can see how it's working. Now, what we are going to do is, because you know the purpose of a default route, if there is no route in the routing table to the destination network, it will use the default route. So what we're going to do is leave that default route there, and we're going to go ahead and configure OSPF version 3. Now we'll do it with the router ID. Okay. They say that command is optional. So, well, I'm just going to show you how to do it. You can just enable it on the interface like you would RIP version RIP NG. But we're going to go through the whole shebang. All right. We're going to go through the global, see the message we get, look at the router ID, then enable it on the interface. Okay. So let's go ahead and go to router 1. And right now you see that's all we have. So we're going to do config. It's like a magic show. Things should start appearing. Config T. All right. So again, IPv6, router, OSPF, and a process ID number, right? 1. Boom. You get a message. Hey, OSPF version 3 process 1. Cannot pick a router ID. Can you please configure it manually? Well, that's very nice of you. No problem. I will go ahead and do that for you. Not that I need to, but I will. All right, so I'm going to go ahead and I'll put a question mark there so you can see all the different things that you can do. All right, but we're going to put in the router ID, and we'll use this. It's an IP version 4 format. So this is router 1, so guess what I'm going to use? That. All right, now we're going to go into the interfaces. No network statements. No network statements. Int G0/0, enter. So we go IPv6, OSPF 1. Right, that's the process we're running. What area? Well, we'll just put it in area 0 just to be copacetic with, you know, what you would really do out there in the real world. You would start with area 0. I don't want nobody to freak out because I put area 51 and say, oh my God, that's not the way. Okay, OSPF, in a lab you can do whatever you want. Real world, yes, area 0 is your backbone area. That'll be the first area you put out there. So this is how you would do it. Okay, and then we go up to the other interface, which is G1. And we'll do that. Boom. Now they're both in process 1, which is for the database, local, and area 0. Awesome. All right, so let's go ahead and now go to this router and do the same thing. All right, we're going to do config T. Config T. IPv6 router OSPF 1. Again, my memory. This is why I use the same process ID number. We know we have 65,000 of these guys. So I use 1 for all of them. Just make it easy. And it's politely asking me, could you please? I'm like, okay, no problem. I'll do it for you. That's all good and dandy. It says router 2, 22222. All right. And then int G0/0. All right. And then I'm going to go IPv6 router. Not router. What am I doing? IPv6 OSPF. Process 1 area. We must be in the same area. Just like in EIGRP, we're in the same autonomous system. For OSPF, we need to be in the same area. Why is that? CCNA certification. CCNA certification. Okay, I don't know. Maybe next year, sometime later on this year, who knows? Cisco might say, you know what? I think these guys can handle doing multiple area. But until that point, all you need to be worried about is single area. Everybody needs to be in the same area. Hit enter. Then the next interface, 1. And then we go up into the area. Boom, done. Whoa, look at that. Full loading done. That's what you want to see, remember? Just like with IPv4. You want to see that. Now, again, just like the other protocols, nothing has changed. Except for the configurations, obviously. All right, but, you know, in the multicast updates with the FF02, ::5 and ::6, other than that, you know, it's OSPF. It bases on cost. It uses the Dijkstra. Everything remains the same. All right, you can have, you know, friggin' 200 million areas, billion, whatever. All right, so let's take a look at the routing table. Do show IPv6 route. I don't need do here. Show IPv6 route. All right, so there we see O's. Now I get O's. We also have a default route. So if the route wouldn't be in there, we'll use this. But since we do have a route to that network, RPC, that's never ending. Which one was it? Was it this one? Yep, sure was. There we go. Now we're getting replies again. Let's stop it from pinging. And let's come up and let's do 2. Just to see something different. And you can see that it pings. So we have connectivity right now via OSPF. All right, that's what's taking over because we have a route in the routing table. If that route wouldn't be there like before, we would use the default route. All right, so let's show IPv6 route again. And there you go. We have an O for the 3000 network. Now, things that you do, show IPv6 OSPF database. Okay, you want to take a look at the database. It tells you the link type that you have, all right, of LSAs, all right, that you see here. And you see that it's using the router IDs, all right, which is the one that we hard-coded onto the router. If you were to look at the show IPv6 OSPF interface G0 / let's look at 1. Let's look at that one. Okay, you see that you have it's a broadcast type. Why is it a broadcast type? Because it's Ethernet. And you see you have a designated router and you have a backup designated router. Now, obviously, the designated router that came up first was this one. That's why I was choosing that one. And the other one, remember the OSPF election process when it's on Ethernet networks or multi-access networks. So we can play around with this again and start, because it should be the designated router should be the higher router ID. But hey, it's all good. But you see you have a priority of 1. So things pretty much stay the same. It's just the IP addresses that are being changed. Now, one interesting thing that you want to look at, if you can see here, this is a link local address. Okay, link local address in combination with our address. Okay, if you see this is a link local address, this is the UL bit right here that got turned into a 2 and is being padded by EUI64. All right, the hellos and deads are the same. All right, that hasn't changed. So as far as the CCNA is concerned, you won't be configuring OSPF version 3. Highly doubtful. I don't think you'll be configuring any of the routing protocols for IPv6. But hey, just in case if you do, now you know how to. Okay, for OSPF, what do? We simply went and said, hey, IPv6, and I'll put it in Notepad so you guys can see it. Let's go ahead and open up Notepad. All right, you first went into global config and you said IPv6 router OSPF and then the process ID number, and then it politely asks you, hey, can you please set up a router ID for me because I couldn't. So you can do it. It's optional, router ID, but Cisco likes you to hard code the router ID, so go ahead and do so. All right, and then you go into the interfaces. All right, and let me make a statement there. This is under global config. Okay, and then up here, this is under the interfaces. Okay, you go IPv6, OSPF, the process ID number you chose, which is 1, and then the area you wanted in. When this case, we use 0. And you will do that under each interface that you want to participate in that particular process, that you want to participate in that area. Okay, and remember, for OSPF, or it's already in caps, single area OSPF, all right? Single area OSPF. So that's it, really. I mean, it's not such a big deal. Good thing is we don't have to worry about any network statements, so it makes things a lot easier. But that's it. Not much to it. Everything else remains the same that you know already from OSPF. All right. So there's your OSPF and your default routes. In the next lecture, we're going to get into auto config. All right, the auto configuration. That's the new feature with IPv6. I'll see you guys there.